Okay, it is now being recorded. So we started normal distribution last time. So if you it is a continuous random variable. Normal distribution is a continuous distribution. We studied continuous distribution in detail as well. So we said this is a norm. Any function that has this shape is a normal curve. We we call this a normal curve, right? This one. So any variable or not continuous variable that whose PDF has this shape is called a normal uh, distribution. So a variable is said to be normally distributed or to have a normal distribution if it has the shape of a normal curve, right? So any distribution who has these shapes are called normal distributions. A normal distribution is completely determined by mean and standard deviation. So if your mean is given mu and standard deviation is sigma, right? Then it is completely determined. So see here, this green curve has mu minus 2. Mu is the middle point. Because it's a symmetrical distribution, mean has to be in the middle. Mean and median are equal when it is symmetrical, right? So mean is in the middle, you see here. So this is your mu minus 2. And if sigma is 1, you have a nice spread. Sigma gives you the spread of the distribution, right? So see here, mu is 3. So you see your mu is 3 here. This is your mu. And now sigma is little smaller. You see here sigma was 1. So here sigma is smaller. So you see the spread is little smaller. So spread is smaller, right? Less spread here because sigma gives you the spread. And here sigma is even bigger than 1. So see, very flat distribution means the spread is too much here, right? So more spread. And this is mean, which is 9, right? So mean gives you the location basically, and sigma will give you the spread, how flat or how tall your distribution is. If mu gives location, where is the central point, right? The central point of the distribution. But sigma will give you the spread. So basically, if sigma is small, then distribution is taller and less spread out, right? If sigma is large, then it will be shorter, it will not be taller and more spread. Shorter and more spread out. Okay, so this is your this is what is going on. But if you want to find the area, the probability of a normal random variable at a single value is 0 because it's a continuous random variable, right? So it has to be 0. So they will not ask you what is the probability of at x equal to 8 will be 0. So we always find the probability in interval. We know that whenever we discuss continuous random variables, we go in the interval. So what is the this one? If you recall the shape of this normal distribution, if I have a space here, maybe. Um, if I add a slide, let's say, how can I insert slide? New slide here, right? A blank slide. The shape basically has this affects the PDF of the normal distribution. For normal distribution or normal random variable is given by 1 over 2 pi sigma e to the power minus x minus mu over sigma whole square. And this is for all x minus infinity to infinity, right? So this, if you draw the graph of this, you will see that it's exactly this one, okay? Where mu is here and so on. So you see, if I ask you to integrate, if I ask you to find the probability between a and b, you have to integrate from a to b this function. And this function is not possible to integrate. So we can only use numerical integrations here. So no integral here. So can only use numerical methods here to find the answers. In last class, I give you details. So instead of that, what have they done? They said, okay, we have some tables. So instead, we have some tables. That gives you the areas or probabilities. So the values are given here and values are given here. We can find the appropriate value from the table. Before going to the table, because there are too many mu and variance. Uh, if X has a normal distribution with mean mu and sigma S, right? What does this mean? It means X is normally distributed or X has normal distribution. X is normally distributed with mean mu and with standard deviation or variance sigma square and standard deviation sigma, right? This is what it means. So if you have this normal distribution, there are too many normal distribution because there are too many choices for mu and sigma, infinite many choices for mu and sigma. 0, 1, 1, 1, 1, 2, 2, 1, minus 2, 3, whatever, right? You can have many choices for mu and sigma. So how many tables we will make? So instead of that, they have just one table, which is called a standard normal table. Standard normal table, which comes from a variable with mean mu 0 and sigma 1. So we fix standard means standard normal variable is any normal variable whose mean is 0 and variance is 1. But now where we can find that if mu is not 0 or sigma is not 1, then what we will do? So what we do is we use the transformation. Any random variable is given. If any random variable is given, what we do is we define a standard normal variable. You see here, a normally distributed variable having mean 0 and standard deviation 1 is called a standard normal variable. So normal curve is given by this. So it is always very nice. It will not be very tall, not be very short. It is always located at mu is equal to 0, right? And sigma is 1. So it's very nicely shaped distribution. It will not be very tall like that. It will not be very short like that. Okay, where sigma is less than 1, sigma is greater than 1. So you are in the middle somewhere here, right? You are in the middle, a nicely shaped distribution, sigma 1. So this is a standard normal distribution. So what we will do, whatever normal distribution is given, let's say if X has a normal distribution with mean mu and variance standard deviation sigma, then we define a new variable z, which is x minus mu by sigma. And this z has a standard normal distribution. Whatever mu sigma you have, you can easily show that. What will be the mean of z? Mean of z will be mean of x minus mu over sigma, right? And we know that exponential expected value is linear. It means I can write constant outside and expectation will go inside. Expected value of x and mu will remain mu because it's a constant. And now you know that expected value of x is also mu. So mu minus mu 0, 0 by sigma is always 0. So see, the mean of this variable is 0. Similarly, if you try to find the standard deviation of this z, right, and solve it, you will see that it is always 1. So this z has a normal distribution with mean 0 and standard deviation 1. That's why it is called a standard normal distribution. So for example, if your x is normally distributed with mean 2 and variance, let's say this one, 20 and 5, right? Then you can define z, which is x minus mu 20 by 5. Then this z is normally distributed with mean 0 and variance 1. Automatically, x minus mu by sigma will always give you a standard normal variable. So what is the benefit of this? The benefit is that whatever standard normal distribution is given, we can convert that to just one standard normal. So see here, your mu is 2 and sigma is 1. So if you write the transformation, it is x minus mu over sigma. This will change this green curve to this blue one. You see, they have the same height. Why? Because sigma was already 1. So height did not change, but it came to 0. You see, it translated to the right side, and now it is at 0. Right? So the position has changed. Here mu was 3 and sigma 1/2. So I can write z as x minus 3 by 1/2. So this will move to the left and it will come down as well because my sigma was half, so it was very tall. When I divided by half, it became little shorter and it came to the same height here. Came to the same height. And whenever you move something, let's say if it was tall, so if you are moving it down, automatically from the sides it will go outside. So it will become like this, a little like this. Okay. And here you see sigma was 2, bigger than 1. It is at 9 as well. But here if I write x minus 9 by sigma, x minus 9 by 2, it will go little up because it was shorter, and it will also go to the left. It will come to 0 and it will become little taller again. So it will again take the same height as this one. Okay. So all will have the same height. So see, all these three different distributions have converted to exactly same normal distribution with different transformation. You see, every distribution has its own transformation, but the final result is the same. Final result is the same. Okay. So no matter what mu and sigma is given, once you write x minus mu by sigma as z, z will have a standard normal distribution. Now, if you want to find the probability of x being between any two values a and b, what you will do, you will convert because mu and sigma are given. So you have defined x as z as x minus mu by sigma. Now, whatever mu sigma are given, you are looking at x between a and b. So what we will do, we will write a in z. What is a in z? By putting x is equal to a. So a minus mu by sigma will become the value of z. So see, a becomes A minus mu by sigma. And X becomes Z and B will become B minus mu by sigma, right? Because when I replace B in Z, so it will become B minus mu by sigma. So they share the same probability. Now, if with this mu and sigma, this is the normal curve and you are looking at the probability between A and B, right? This area under the curve. But after this transformation, my shape of the distribution has changed. But my A and B has also changed, right? So we are claiming that this area is exactly the same, equal areas. The area with mu sigma between A and B and area with 0, 1 mu sigma between A minus mu and B minus mu by sigma gives you exactly same probability. So they will not change. Okay. So these probabilities will be preserved. The total area under the standard normal curve is 1. Not just the standard normal curve, the total area under any normal curve is 1. Okay. The standard normal curve extends from minus infinity to infinity. It does not stop. You can see that it's almost, this point is almost minus 3.5 and this point is almost 3.5. But it starts from minus infinity and it is continuing towards infinity. It never stops. Okay. So from minus infinity to infinity. But if you look at the area after minus 3.5 and after 3.5 here is very, very small. So almost all the area is between minus 3.5 and 3.5. I think almost from minus 3.5 z less than 3.5. I think it almost 0.999 area is there. 99.96 or something like that. Okay, so see almost 1. So normal curve, standard normal curve does not go. If you write it in X, then it is almost plus minus 3.5 sigma, right? Because Z is X minus mu by sigma. So X will become mu plus Z sigma. So if you put Z minus 3.5, so this will give you X as mu minus 3.5 sigma less than X less than, and this will become mu plus 3.5 sigma. So almost, right? So it means if mu is in the middle, then this is mu plus 3.5 sigma almost, and this is mu minus 3.5 sigma. So almost all the probability is taken between plus minus 3 standard deviations, plus minus 3.5 standard deviations. So now there can be different scenarios. Finding the area to the left. I think this was finding area to the left of a specified value. So if the area, any z value is given and you want to find from the table, it will come directly from the table. Why? Because table gives you the areas to the left. I can show you the table. This is standard normal table which I uploaded there. So you see here, if you look at the picture at the top, you see this is the area mentioned, the left. If any z value is given, area is on the left here. So let's say if I look at this point, right? So this is the point. Z is minus 3.2 and here it's 0.03. So this is the first one, means minus 3.2, and that is the second decimal place. This is the second decimal place. Okay. So this is the probability to the left of this Z value, which is 0.0006. This value is to the left of your Z. So Z was minus 3.23. So if you want, let's say area, let's say to the left of 0.67, let's say 0.67. So 0.6, we will look at 0.6 on the left and this 7 at the top. So this is on the left side and 7 is on the top, this one. Okay, so 0.07 is this. So here, this is the, if you go down from here and go to the right from here, so see, I got here and this one. So this is 7486. So this is 7486. So these are the table which were made by doing the integration. Basically, you see here, this probability is actually from minus infinity to 0.67, and standard normal is sigma 1 and mu 0. So this is e to the power z square dz. This integration was done using some numerical methods, and they found out that this should 7.748C. So there is a lot of effort to get this one value. So you see, if you look at this whole table, I think there are 35 values here and 10 values here. So 350 values on the right and 350 values on the left. So almost 700 values are there in the table. So basically they have approximated 700 different integrals to get these values. Okay, for every value they are approximating one integral. So they have done a lot of work to establish this table, and this table was made maybe 100 years ago. So not the computer software were not available to them. So most of the part they did it by hand. So what was that value here? 1.23. So if I look at 1.23 in the table, 1.23 is, you will look at 1.2 here, 1.2, and this is 0, 1, 2, 3. We start from 0. So don't count the third table. The third table is 0.2. You see, the third table is 0.2. The fourth column is 0.03. So 1.23 is this fourth column, 0.8907. And you can see here it is 0.8907. See? 0.8907. So this is the area here. What if you want to find the area to the right of a value, specified value? So on the right side, table does not give me this. So table will give me this one, right? From table, I will get the left side only, right? Left. So what I will do, I will subtract the left area from 1 because the total area is 1, right? So if I subtract the left area from 1, I will get the area on the right. So if you look at this one, it is 0.76. So if you look at 0.76 in the table, you will get 0.7764. So if you subtract 1 minus 0.7764, this is the area to the right. And the third possibility is that you have to find the area between 2 points, right? So if you are finding between 2 points, again, if I look at this in the table, it will give me area to the left of this point. If you look at 1.82, it will give you area to the left of 1.82. So what I can do, I can subtract this one. If I subtract this, I will get the remaining portion. So you can take the area at the right side, area at 1.82, and subtract the area which is on the left side. So this is the area that you will get in the middle. Okay. So area at 1.82 is this 0.9656. Area at minus 68 is 0.2483. You can see in the table, I can show you 1.82 and 0.68. Let's say 1.82. So 1.82 is this 1.8 and 2.9656, and second one was minus 68. Minus 68 is here, minus 6 and 8 is the second, 2483. So see, 9656 and 2483. Clear? So these are the two areas. So then you can subtract and get the answer. So this gives you the probability, basically. Saying it as area or probability, it is the same thing. The probability between these two z values, 1.82, is equal to this. Area at the right point minus area at the left point. So these are the three scenarios you can check. So when I write A at Z, it automatically means that area to the left of Z. Area to the left of Z. Okay, automatically means that. So basically, this also gives you the probability that Z is less than this value Z. Probability area is the same thing. Okay. So I can go to a question, an example. You see, intelligence quotients are normally distributed with mean 100 and standard deviation 16. So see, mean and standard deviation is given. Always, they will always be given, right? Determine the percentage of people who have IQs between 115 and 140. So first of all, I will say that I will define my normal random variable because intelligence quotients are normally distributed. So I will say that let X be the intelligence quotient level. Then X has a normal distribution with mean 100 and standard deviation sigma because they are given, right? So from here, mu is given as 100 and sigma is given 16. Now, first step is that if you can sketch a normal curve, that's the best thing we can sketch. So if I sketch a normal curve, 100 is in the middle because 100 is my mean, right? And sigma 16. And they said, and then select the region of interest. Region of interest means what they are asking. They are asking me the probability between 115 and 140, right? So I can draw 115 and 140. Now, with that, I can also draw a z axis. I can also draw z axis. That my z is going from z becomes these two values. So I have to convert these two values to z. So if when x is 115, my z is 115 minus mu by sigma. 115 minus 100 by 16. 15 by 16.94. Then when x is 140, it becomes 140 minus mu by sigma. That is 2.50. So the same value becomes 0.94, 2.50. It means the probability of x being between these two values is the same as z being between 0.94 less than z less than 2.5. This is what it is. Okay. So this means the area at the right point, which is 2.5, minus area at the left point, which is 0.94. So this is the area at 2.5. This is the area at 0.94. So when you subtract, you got this one. The question was not the probability. They said, what is the percentage of people who fall in this level, fall in this IQ level? So what I will do, I will multiply my answer by 100 to write the answer in percentages. Hence, the percentage of people who have IQ level between this one is 16.74%. Okay. So this is another example, which is solved example. Mean values is given. You can go through that. I can pick a question from, let's say, exercises. Uh, let's see if I put this and here there are um, questions from normal distribution here. These are. So these, see, the first question here is they are straightforward because simply they are asking me what is the area to the left of Z, to the right of Z. So we know how to do that, right? Between these two values. Actual issue is when it is given as a problem. Let's say question number 15. 'I think I wrote here which questions you have to submit. Uh, 15, 16, 13, 15, 16. So I can pick 17 maybe. 13, 15, 13 is easy, 15 is also easy, but 16, um, so here you see here, um, a soft drink machine is regulated so that it discharges an average of 200 milliliters per cup. You know, if you go to any KFC, McDonald's, there are soft drink machines, right? You just press the knob and they give you the drink. But some drinks which are vending machines, for example, here in university, you see vending machines. If you just press the button that give me a cup of tea or coffee or whatever drink you have, it discharges automatically the required amount, right? So they said a machine is regulated that in a cup, he will uh, put 200 ml of water. So maybe this cup contains up to here, right? 200 ml of water. So it is regulated to fill the cup up to 200 millimeter, but it is on the average, right? So if I say that let X be the amount of drink, right? Let's see. So here you see if the amount of drink is normally distributed with standard deviation 15 milliliter. So see, then X is normally distributed with mu and sigma, where your mu is given as 200 ml, right? And sigma was given 15 ml. So sigma means there is some variation. It means it is, after all, it is a machine. So maybe it sometime it discharges more than 200 ml and sometimes less than 200 ml, right? But nowadays machines are very good. So sigma is very, very small, right? Almost all the drinks are equal, right? But there can be some variations, you know. If you buy some soft drinks outside, a can of soda, usually, you know, they write 200 ml plus minus 5 ml, right? It means this is the error that you can expect. Maybe some cans have 195 ml of liquid and some may have 205 ml of liquid, but most of them will be in the middle of these two values, right? So this is the error which is compensated by the machines. Anyway, now whenever you write x, straight away define z. What is your z? The variable z is x minus mu by sigma. So your x minus mu is 200 and sigma is 15. And this has a normal distribution with zero mean and unit variance, right? Or we can say that then this z is a standard normal variable, right? So whenever x is a normal distribution, then this z becomes standard normal variable. So that's okay. We found the standard normal variable. Now what we have to do? Now we will answer the questions. The first question is, what fraction of cups will contain more than 224 milliliter? So are there any cups that contain more than 224, right? Greater than 224. So see, if I draw normal curve, right? 200 is in the middle, so 224 will be somewhere here. So I'm asking you this. Okay, so going back here. Uh, so 224. Now I will write 224 in Z. So when X is 224, my value of Z will be 224 minus mu by sigma. So 24 by 15. So 15 ones are 15 and 15 6 are 90. So that is probability of Z greater than 1.6, right? So if I draw a Z value here, this is 0. So this is almost 1.6. So I'm getting this area on the left. You know that area on the left is not direct. It is 1 minus area on the left. Area on the right is 1 minus area on the left. So this means right. Right? So this means the area on the right, and this is the area on the left. So 1 minus area on the left. So this is what I will get. So area on the left is written as area, 1 minus area at 1.6. So what is 1.6? Here is the table. So 1.6. 1.6 under 0. So this is 1.6 under the first column. This is 0. 0.9452. So 0.9452. And if you subtract, I think it will be 0.8450, right? 548, 0548. So this is the fraction of the cups who will get the liquid or drink amount more than 220. So see, very less. Only 5.5% of the cups will get this huge amount. The second problem is, what is the property that it contains between 191 and 209, right? So it means you will find what is the property that it will contain 191 and 209, right? So I will convert this to Z. So I will find the values of Z. What are these values? So 191 minus mu by sigma, which is minus 9 by 15 minus 0.6. And then 209 minus mu by sigma. So that will be 9 by 15. So that is 0.6. Right? So I can write minus 0.6 and 0.6. So you know that this is the area at the right point minus area at the left point, right? So if you draw this curve, 0, so minus 0.6 plus 0.6. So this area, right? Minus 0.6 plus 0.6. So it is the area at 0.6 and this is the area at minus 0.6. So we will subtract. To get the middle area, we will subtract this one from this whole area. So area at 0.6, area at 0.6 is this one, 0.6 under 0, 7257. 7257 and then minus area at minus. So minus is above here. So minus 0.6 here, right? Minus 0.6 under 0, 0.2743. 0.2743. So if you subtract, you will get the answer. So whatever the answer you can write here, okay? Then C part. C part is how many cups will probably overflow if 230 milliliter cups used. So see, the cup has the capacity of 230 milliliter. They said, what is the probability that it will overflow, right? It will overflow. How it will overflow? When X will become more than 230, right? And out of 1,000 drinks means next 1,000 drinks. So it means I will find the probability first, that what is the probability that it will flow, right? Over 230, find that. And then what fraction, how many cups? He said how many cups will overflow. So we are considering 1,000 cups. So we will multiply that with this probability. This is the probability of overflowing and multiply by total number of cups. So this will give you the number of cups that will overflow. Okay. So this is the same as the first part, you see. First part is X greater than 224. So you 224 is 30 now. So if you write, you can write property of Z greater than 230 minus mu by sigma. 230 minus mu by sigma. So 30 by 15 is 2, right? So it is 1 minus area at 2. So you can find 1 minus area at 2 and get the answer. That you will put here and multiply. That will give you the total number of cups. The last part is little interesting. Here you see the last part is below what value do we get the smallest 25% of the drinks. 25% of the drinks means this is the probability of something. And below what value means they are asking me X. So see, it is the opposite question, reverse use of table. So they ask me that find X such that, you see, they ask me this thing, that find X, the middle is your mu. So find X such that below this point contains the 25%. 25% means 0.25, such that probability of X less than this value is 0.25, right? What below what value? So below means on the left. Below what value? The smallest 25% of the drinks. So these are the smallest 25%, right? So that is what it's the inverse use of table. So basically, so let Z is equal to X minus mu by sigma. Then X will become Z mu plus Z sigma plus mu, right? I can multiply mu sigma here, Z sigma, and mu will be added there. So this is what I want, but I need the value of Z first, right? So where your Z is, if Z is this, then probability does not change. You see, if I write Z here, the probability will remain the same, 0.25. So it means I am looking for a Z whose area below it is 0.25. That's what I'm looking for, right? So I know that from the table, area, which value gives me area 0.25. So I will look inside the area now. I will look for the area which is 0.25. This one, right? These both are basically close. This is, I think, more closer. 0.25 is, this is 14 units away from 25, and this is 17 units away from 25. So see here, this is, what is the Z here? 0.2514. Z is 0.6 minus 0.6, 0, 1, 2, 3, 4, 5, 6, 7. So this is minus 0.67. And this is the other one. This one is minus 0.68, gives me 0.2483. So I can take any one. I can take this one because this is closer. Or if you want to do better, maybe you can get the middle value. You can take the middle value of 0.67 and 0.68 divided by 2. So that will become minus 0.675. So 0.675 will give me the middle value, which will be much closer to 0.25. Okay, so it means area at minus 0.675 will be very, very close to 0.25. Okay, very close to 0.25. But you can pick 6, 7 as well, no issues. The answer will not be wrong. So I can see that this gives me Z is equal to minus 0.675 from the table. Okay. How I got that? I got this from table. So this is the reverse use of table. So what I did here is a reverse use of table. Before Z was given, I was looking for the area. Now the area is given and I looked for Z. So this is a question where you use table in reverse. Now I will put the Z value. So therefore, from equation 1, I can put Z here, right? So my X will become mu plus Z. Z is minus 0.675 and sigma is 50. Okay, so this will give me 200 minus 0.675 into 15. 189.875, right? So almost 190. You can say that almost 190. So below 190, you will get 20% of the 25% of the drinks, smallest 25% of the. Okay. All right. So I think that should be it. So you can try other questions. A research scientist reports that mice will live an average of 40 months when their diets are restricted and then enriched with vitamins and proteins, assuming that lifetimes of mice are largely distributed. So what you will do that lifetimes of such mice, right? So I can say that let X be the lifetime of mice, right? Then they said it is normally distributed with standard deviation of 4.3. Then your X lifetime is normally distributed with mean, mu, and sigma, where mu is 40 months, you see, an average of 40 months, and sigma 6.3 months, right? Now we have to find the properties, but right after that, we write Z, which is X minus mu by sigma, right? So this is standard normal variable. So right there, I will write that this is a standard normal variable. Now I can answer anything more than 32 months, less than 28 months, between 37, 49. So we can clearly solve this question, no issue, right? But you should remember the criteria. That criteria is whatever question is given, that question is for X. Then we will convert my question to Z, right? By changing this 37 minus 40 by 6.3. This will come here, right? The other one is 49. So 49, you can do it aside somewhere here. 37 minus 40 by 6.3. That is your Z1 comes here, right? And 49 minus 40 over 6.3. That is your Z2 comes here. Okay. So you can write Z. And then because it is between two values, so I will write area at the right end point and minus area at the left end point. Then we will use table to write these two areas, subtract and get the answer. So it's not difficult, very easy, very interesting topic, normal distribution. So you can pick other questions as well and solve them. Okay. I hope this will help. So that's all for today from my side. If you have any questions, you can answer, you can ask. But before going, all right, so I'm stopping the recording here. But